Good day, students. This time we'll be having another lesson in mathematics in the modern world. This is your instructor, Mr. Japheth and Nabaira. But before that, take note of these two important features of the EMODULE. The first one is the checkpoint. If you will see this feature across the EMODULE, it conveys that you have to check your progress. It could be a practice exercise, a drill, or a thought-provoking question that will solicit your answer to better understand the topic discussed. Another feature of this EMODULE is the key to correction. This feature in the EMODULE will give you immediate answers to the questions that are posted in the checkpoint section. No explanations will be provided to generate your own justification of the answers, hence enhancing your creativity and critical thinking abilities. That's why you really have to take note of these two important features of this EMODULE, because these two features might pop up in any part of the EMODULE to check your progress. Alright, this time we'll be exploring EMODULE 3.2, Polya's 4 steps in problem solving. For your learning objectives, at the end of this lesson, the student should be able to identify Polya's 4 steps in problem solving and solve problems using the organization of Polya's 4-step problem solving process. As an overview, one of the primary reasons people have trouble with problem solving is that there's no single procedure that works all the time, because each problem is slightly different. Also, problem solving requires practical knowledge about the specific situation. If you misunderstand either the problem or the underlying situation, you may make mistakes or incorrect assumptions. Therefore, it is often useful to get used to an organized approach to problem solving and decision making. That's why in this lesson we'll be exploring Polya's 4 steps in problem solving as an organized approach in solving problems and decision making. Though there is no single procedure that works all the time, this procedure of Polya is generic in nature. So let's be acquainted first about who is George Polya. And here is his picture. After a brief stay at Brown University, George Polya moved to Stanford University in 1942 and taught there until his retirement. While at Stanford, he published 10 books. That is very prolific, and a number of articles for mathematics journals. Of the books Polya published, How to Solve It in 1945 is one of his best known. In this book, Polya outlines a strategy for solving problems from virtually any discipline. Hence, this strategy is very generic. That's according to Hoffman. Here is George Polya, and we owe the 4-step problem-solving strategy to this brilliant mathematician. To continue, what is Polya's 4-step problem-solving strategy? Here's how it is. The first one is understand the problem. Of course, that's the very first step. The second one, devise a plan. The third one, carry out the plan. And lastly, review the solution. This is the very famous Polya's 4-step problem-solving strategy. Polya's 4 steps are deceptively simple. To become a good problem solver, it helps to examine each of these steps and determine what is involved in every step. Using a 4-step procedure for problem solving, Polya's book demonstrates how to think clearly in any field. So basically, this problem-solving strategy can be applied in business, in education, in mathematics, or in any other fields. That's why it's very generic. Did you get it? Alright, let's examine each step in this Polya's 4-step problem-solving strategy. The first one is understand the problem. What does it mean? This part of Polya's 4-step strategy is often overlooked. Maybe because other problem solvers are very adept in understanding problems. But you must have a clear understanding of the problem. Of course, when you start solving problems, the first step there is to understand the problem. To help you focus on understanding the problem, consider the following questions. This is according to Hoffman. First, can you restate the problem in your own words so that you can understand it better? Can you determine what is known about these types of problems? Or maybe you have encountered such type of problem before? Next, is there a missing information that, if known, would allow you to solve the problem? Of course, sometimes there are implicit given. Is there extraneous information that is not needed to solve the problem? This is very evident because sometimes there are extraneous information in the problem that makes the problem confusing, but actually they are not part of the solution. And lastly, what is the goal? So you really have to know what is asked in the problem. Okay? Now, in the second step, devise a plan. Successful problem solvers use a variety of techniques when they attempt to solve a problem. And here are some frequently used procedures. The first one, make a list of the known information. It's very true because you really have to take note of the known information. Then make a list of information that is needed. What are the unknowns or what are the needed information? Draw a diagram. This is one of the strategy. Make an organized list that shows all the possibilities for the solution. Make a table or a chart. Work backwards. The latter 4 here are very popular problem-solving strategies. So you can use this in planning for a solution in the problem. Now, we still have other strategies. Try to solve a similar but simpler problem. Now, sometimes the problem is very confusing, very complicated, but you can solve a similar problem that is simpler than the given problem. Look for a pattern. Sometimes this is very useful because when you can find pattern in the given problem, most probably it's very easy for you to solve the problem. Write an equation. This is very popular in algebra because you represent problems with variables. Perform an experiment or you act out the problem. And guess at the solution and then check your result. This is popularly known as guess and check strategy. So something to do with trial and error. Did you get it? So these are some of the problem-solving strategies that you can use in devising a plan to solve a problem. What about the third step? Carry out the plan. Of course, once you have devised a plan, you must carry it out. And what are the things that you have to take note in this step? Work carefully. Sometimes carelessness will lead us to wrong answers. Keep an accurate and neat record of all your attempts. Like scientists and mathematicians, they always keep their attempts. Maybe there are missing links in the solution that they can find in other records of their solutions. Realize, this is very important, that some of your initial plans will not work. Nobody is a perfect problem solver, and that you may have to devise another plan or modify your existing plan. Sometimes when we solve problems, we can experience failures, we can arrive at wrong solutions, but do not be discouraged. Take note that very good problem solvers do not quit. If the initial plan did not work, then try another plan. Maybe you can think of a possible plan that is better than the initial plan. Did you get it? So problem solving requires a lot of patience. Now, the last step is review the solution. Once you have found out a solution, check the solution. Sometimes, especially in algebra, we have the so-called extraneous solutions. Those are solutions that we have arrived actually using the process, but when you're going to substitute it with the original given, it will not satisfy the given. Hence, they are called extraneous solutions. Here's how it is. Ensure that the solution is consistent with the facts of the problem. This is very true because sometimes, especially in algebra, when we have already found the value of x, we stop there and consider the value of x as the answer. But actually, there are still many conditions in the problem that must be satisfied. So that is not the right practice. Now, interpret the solution in the context of the problem. Practical applications. Lastly, ask yourself whether there are generalizations of the solution that could apply to other problems. This is very true because sometimes if we can see patterns in a certain problem, then eventually you will realize that this can be applied actually to other problems. And with that, you are enhancing your creativity and critical thinking. Is that clear? So I guess after this lesson about problem solving, you will be very good problem solvers. Okay? So let's start the ball rolling. But before that, let us first have a checkpoint. If you can still remember the 4 steps in Polya's problem solving strategy in proper order. Can you still remember them? Okay, I think they are very easy to remember. So, here's now the key to your correction. What are the steps again? The first is understand the problem. The next, devise a plan. Next, carry out the plan. And lastly, review the solution. These 4 steps must always be in your mind, especially when you want to become a good problem solver. Is that clear? Alright, let's continue. Let's try to apply Polya's strategy. In this first problem, we will use the guess and check strategy. But still, we'll be following Polya's 4-step problem solving process. Here's the problem. The product of the ages in years of 3 teenagers is 4,590. None of the teens have the same age. What are the ages of the teenagers? So we can solve this problem using guess and check. Now the first step is understand the problem. And how are we going to understand that? We need to determine 3 distinct counting numbers from the list 13 to 19. Why? Because we're dealing with teenagers. And when we say teenagers, it starts with 13 to 19 from the word teen. Did you get it? Then you will find a combination of these numbers 13, 14, 15, 16, 17, 18, and 19. 3 combination of these numbers that will give you a product of 4,590. Okay, let's proceed to the second step, and that is devising a plan. If we represent the ages, since we're looking for 3 ages as x, y, and z, then the product of x, y, and z must be 4,590. We're unable to solve this equation, but notice that 4,590 ends in a 0. Hence, 4,590 has a factor of 2 and a factor of 5, which means that at least one of the numbers we seek must be an even number, and at least one of the number must have 5 as a factor, because when you multiply 5 with an even number, that will give you 0 in the units digit. Did you get it? Alright, the only number in our list that has 5 as a factor is 15. So most probably 15 is one of the numbers, and at least one of the other numbers must be an even number. From the word at least, that is, one of the two numbers must be even or both numbers must be even. So let's try to carry out the plan. We have now the third step. At this point, we will solve the problem by guessing and checking. We have a first guess. Since we know that 15 is one of the numbers, and at least one of the numbers must be an even number, then we'll try 16 and 18. But that gives you 4,320. But this product is too small. So let's try to increase 16 and 18. Okay, so let's try 19 instead of 18 to raise the product. 15 times 16 times 19 will give you 4,560. And this is still too small because we're looking for 4,590. What about let's try to increase also 16? Let's try 15 times 17 times 18. Still, we have at least one even number, and that is 18. So that will become 4,590. And it's a yes. This is the correct product. And it's a yes. This is the correct product now. So we can say that the ages of the three teenagers with the product of 4,590 are 15, 17, and 18. Let's try to review the solution. This is the last step. Because 15 times 18 times 17 will give you 4,590, and each of the ages represents the age of a teenager, we know that our solution is correct. But can there be other solutions? None, of course, because the remaining ages of the teenagers 13, 14, 16, 19, neither of them is a factor of 4,590. So basically, there are no other solutions. We only have one solution, and that is 15, 17, and 18. So the ages of the three teenagers are 15, 17, and 18, and the problem is now solved. Using Polya's four-step problem-solving process through guess and check strategy. Did you get it? Alright. It's now your turn, of course, to practice on how to solve a problem using Polya's four-step problem-solving process through guess and check strategy. Okay, so here's now your problem. In the World Math Competition held in the Philippines, the contestants were given 10 items to be solved in 4 hours. 5 points were given for each correct answer, and 2 points were deducted for each wrong answer. Albert did all questions and scored 29. How many correct answers did he got? Now, you can solve this problem using guess and check strategy because there were only 10 questions or items to be solved. Okay? So maybe this will take for 2 minutes or at most 3 minutes for you to solve the problem using guess and check, following Polya's four-step process. And again, you can pause this video for a while, then you can check your answer to view if your answer is correct or not. Did you get it, everybody? Alright. I think you have now your answers. So here's now the key to correction. The answer is Albert got 7 correct answers. Do you have the same answer? Alright, I think it's a yes. Okay, so let's proceed with still applying Polya's problem-solving strategy, but this time we'll be making an organized list. Here's the problem. A baseball team won 2 out of their last 4 games. The question is, in how many different orders could they have 2 wins and 2 losses in 4 games? Okay, so the question is asking us, in how many different ways or orders can this baseball team have 2 wins and 2 losses? So let's start solving the problem. What's the first step? understand the problem. There are many different orders, of course. The team may have won 2 straight games and lost the last 2 because there are 4 games. Or lost the first 2 games and won the last 2. Of course, there are other possibilities such as win-loss, win-loss, or WL-WL. W will represent win and L for loss. So basically, we have to list all possibilities. Let's devise a plan. And how are we going to do that? We will make an organized list of all the possible orders. An organized list is a list that is produced using a system that ensures that each of the different orders will be listed once and only once. This means that in an organized list, you're going to write every order, but you are following a system. So what is our system here? Each entry in our list must contain 2 W's and 2 L's. So we cannot have 3 W's and 1 L or 3 L's and 1 W. We will use a strategy that makes sure each order is considered with no duplications. And with that, we are using an organized list. Okay? Let's carry out the plan. One such strategy is to always write a W, unless doing so will produce too many W's, or a duplicate of one of the previous orders. If it is not possible to write a W, then and only then do we write an L. This strategy produces the 6 different orders shown below. So our strategy here is we will write first a W, but if you have already written 2 W's, then and only then we will write an L. Did you get it? Alright, let's start with WWLL. So we'll start with 2W. Basically, we cannot have WWLL anymore because that's the first order. But we can write WLWL. Start with 1 win, then since we cannot write anymore another W after the first W, then and only then we will write an L. Then another W and L. For the third one, W, L, L, W. Because we cannot write anymore a W after the first L because that will be a duplication of the second order. The next one, L, W, W, L. Of course, since we cannot write anymore W in the first because we already have 3 orders in which W came first. Now for the next order, we have L, W, L, W. And of course, lastly, we'll be having 2 losses and the last 2 wins. So basically, have we forgotten any order out of these 2 wins and 2 losses in the 4 games? I think we haven't forgotten any order, right? So we have just listed 6 different orders. Okay? So let's try to check the solution if the 6 different orders are correct. Now, we have made an organized list. The list has no duplicates. We have seen it, and the list considers all possibilities. So we are confident that there are 6 different orders in which a baseball team can win exactly 2 out of 4 games. Now the problem is solved. Did you get it, everybody? Now you have another strategy. Aside from guessing and checking, you can make an organized list to solve the problem. Of course, there will always be your turn. So this time, you'll be solving this problem using Polya's 4-step process and making an organized list. Here's the problem. To improve her handwriting, Lyrene practices writing the numbers from 1 to 200. How many times will she have written the digit 1 in all? See, this is very easy if you know how to list all the possibilities using an organized list. Okay? So I think it will take at most 2 minutes for you to solve this problem. This is very easy. Hence, you can pause the video again and play it afterwards to view the correct answer. Is that clear? Alright. I think you have now your answer. And here's now your key to correction. So how many times will she have written the digit 1 in all? The answer is 140 times. That means in writing the numbers from 1 to 200, there are 140 ones in all. Did you get it? Alright. Next, we'll be solving another problem using Polya's 4-step problem-solving process. But this time, we'll be making a diagram. See, we started at guessing and checking, we used an organized list, and this time, we'll be making a diagram. Okay, so here's now the problem. 4 runners are in a 1-mile race. Maria, Aretha, Telma, and Debbie. Points are awarded only to the woman finishing first or second. The first place winner gets more points than the second place winner. How many different arrangements of first and second place winners are possible? So this time, we'll be making a diagram to solve this problem. There are 4 runners, Maria, Aretha, Telma, and Debbie. And the question is, how many arrangements of first and second place winners are possible? Because there are only 2 winners, first and second place. Now, let's understand the problem. In our understanding of the problem, 3 possibilities for first and second position are Maria will be the first, Aretha will be the second, then Maria will be the first, Thelma will be the second, or Aretha will be the first, Maria will be the second. But these are not the only possibilities. There are more possibilities. Now, notice that Maria finishing first and Aretha finishing second is a different outcome than Aretha finishing first and Maria finishing second, because order makes a difference in this question. Since the first place winner gets more points than the second place winner. So Maria Aretha is different from Aretha Maria. Because Maria Aretha means Maria got the first place but Aretha got the second place. Aretha Maria means Aretha got the first place but Maria got the second place. So we must count all possibilities for first and second place. How are we going to do that? Let's devise a plan. And what is that plan? If Maria finishes first, then each of the other 3 runners could finish second. We have here a diagram. If Maria finishes first, then the other 3 runners could finish second. That means Aretha could be the second place, Thelma could also be the second place winner, Debbie could also be the second place winner. So if Maria finishes first, then there are 3 possibilities. So basically, there are 3 possibilities if one of the 4 runners will finish first. Did you get it? Now, we will do the same diagram for Aretha finishing first, Thelma finishing first, and Debbie finishing first. And let us count all the possibilities using the diagram. Now, as an extension of devising a plan, similarly, we can list each woman as the possible first place winner. As what I have said earlier, then we will list the other 3 women as possible second place runners. Next, we will determine the possibilities for first and second place. This diagram will show how the runners can finish first or second. Alright, I'm very excited, so let's carry out the plan. Now, we will complete the diagram and count the number of possibilities shown. Let's take a look with these diagrams. For the first diagram, Maria finishes first, but the other 3 runners can finish second. In the second diagram, Arita finishes first. Still, the other 3 runners can finish second place. In the third diagram, Telma can finish first, and the remaining 3 runners can finish second place. And in the last diagram, Debbie can finish first, and the remaining 3 runners can finish as second place. Now, if you're just going to count all the pairs per diagram, in every diagram, we have 3 pairs of possibilities, right? So since we have 4 diagrams, basically, you can have 12 possibilities. Now, let us list all the possibilities. And here are now the 12 possibilities. Maria Aretha, Maria Telma, Maria Debbie. Take note that in this list, the first person listed is the first place winner, and the second person listed is the second place winner. We can also have Arita Maria, Arita Telma, Arita Debbie. We can also have Telma Maria, Telma Arita, Telma Debbie, Debbie Maria, Debbie Arita, Debbie Telma. And as what we have discussed earlier, Maria Arita is different from Arita Maria. So basically, we have 12 possibilities. And we have just solved the problem using the diagram. Did you get it? Alright. To review our solution, you can recheck the diagram to make sure that no possible first and second place outcomes have been left out. Or double check your count for the winning pairs of runners. Maybe there are duplications, but in our list, we have just observed that every possible order was listed once. There are no duplications, and there's no possible order that has been left out. Hence, there are 12 different arrangements of first and second place winners that are possible. The problem is now solved. See, it's just very easy to solve a problem using Polya's problem-solving process. As long as you have patience in solving the problem and you can use a strategy to solve the problem. And in this problem, we have just used making a diagram. Okay? It's now your turn again. So you have to practice. And after this lesson, most probably, you will become the best problem solver that you can ever be. So, solve this problem using Polya's 4-step problem-solving process through making a diagram. And here's now your problem. Your lecture wardrobe, imagine that you are a lecturer, is rather limited. Just 2 pairs of jeans to choose from, 1 blue, 1 black, and 3 t-shirts to choose from. 1 red, 1 yellow, 1 blue. How many different outfits can you form? Okay, this is very easy. You just have 2 pairs of jeans and 3 t-shirts to choose. So you can again make the same diagram that we have done earlier and try to count all the possible outfits that you can have using these 2 pairs of jeans and 3 t-shirts. It's very easy. You can pause this video again for a while and then play it to check your answer. Did you get it? Alright. I think you have now your answers. So here's now your key to correction. How many possible outfits can you have? 6 outfits. See? It's very easy, right? If you know how to solve the problem using making a diagram and with the use of Polya's 4-step problem-solving process. Okay, so you have to take note of this. This is an encouraging statement from George Polya. A great discovery solves a great problem, but there is a grain of discovery in the solution of any problem. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculty, and if you solve it by your own means, you may experience the tension and enjoy the triumph of discovery. This statement is very inspiring because sometimes in our way on becoming a better problem solver, we may experience tension, we may experience failures, but at the end of the day, if you have solved the problem, then you will also enjoy the triumph and victory of being a better problem solver. That ends our lesson in this eModule 3.2 about Polya's 4-step problem solving process, and I hope that you learned something about this lesson. If you want to learn more about this lesson, you can read the following references and peruse some other strategies to solve different problems, but still following Polya's 4-step problem solving process. We also have the following online references, so you can also browse the internet to increase your knowledge about problem solving. Here are the photo credits to the icons and pictures that I have utilized in this eModule. Thank you for listening, have a great day, and God bless everyone.